Welcome back. In this lecture, we're going to talk some more about objects and classes. And in particular, we're going to introduce two new classes, the eye class and the face class that we will draw. And as the name suggests, the face class will draw a face, two eyes, a nose, and a mouth, and a head. And the eye class will be responsible for drawing and moving the eyes. Two main goals for this lecture. One is to reinforce the same basic concepts of objects and classes, constructors, member functions, how to define them and how to call them. And then also, perhaps more importantly, is we're going to see that the face class is itself going to use the eye class. And so this interplay or this use of one class within another is another take-home message for this lecture. So let's go ahead and dive in. Up top, I'm going to import some libraries. I need to draw in the math libraries. And here is my eye class. So notice again, I've got the eye class. I have 1, 2, 3, all indented member functions. The first function, of course, is the constructor, underscore, underscore, init, underscore, underscore. This constructor takes 4 parameters, x, y, rad, and color. The eye itself has one more parameter that's associated with it, which I'll describe in a second, but let me first describe these 4. X, Y is the location of the eye on our canvas. We're eventually going to draw these things, and that tells me where to draw the eye. Rad, of course, is the radius, which is how big the eye is. And the optional parameter color is the color of the iris that you'll be seeing. Remember again that when you define a parameter like this, it means it is optional. If you pass it in, it will override the value here. And if you do not pass it in, well, then that will be the value. Okay, let's go ahead and look at the constructor. I've got my first 3 parameters here, x, y, rad. I'm assigning these parameter names associated with the object, that's self of course, to the values that were passed in with the same name. The color is right here, and this is the direction. So the direction tells me, in fact, let me go ahead and just draw the eye so you can see what we're going to be looking at. So here's the eye. The blue part, of course, is the iris, and I haven't drawn the pupil there, so it's a cartoon eye, if you will. And the direction is where is that small blue circle around the perimeter of the circle. So this is 0 horizontally to my right, and as I rotate, it'll increase or decrease in orientation depending on which way we rotate. Okay? And so the direction I'm going to set by default to be 0. Why didn't I pass it in? No particular reason, mainly to just make a point that not all parameters associated with an object have to be passed in. You can just set some values if you want. That's completely your prerogative to do that. In this case, I just said that the default direction of the eye is always 0. And notice in my comment, I say it's not passed in and that it is defined in radians. That's really important, by the way, when you're talking about directions. Always distinguish between radians or degrees. It's a good way to get bit by a bug. So this is my constructor here. X, Y, radius, and the color and the direction that the eye is looking. Okay, we'll talk about the direction a little bit more in these next 2 functions. So this function lookAt allows me to move the iris of the eye to another location. And the way that is specified is I specify a point LX, LY. That's just some point on the canvas. And so let's say it's this point here, the eye is here. Then the iris should move along the line connecting those 2 points as if it's looking at it. Okay, so this is not a 3-dimensional eye, it's a 2-dimensional eye. It lives in flatland, and so all it can do is rotate like this and just look to a point as if it's doing sort of this. Okay. Now, what is this equation? I'm going to kick out of this Jupyter notebook in a little bit and derive that for you. So for now, it's just an equation that defines the direction from the point that you specify to look at. All right, let's go ahead and look at the draw function now. I'm going to draw 2 circles. One is the outer circle, just a thin black, and then the inner circle, which is the color of the iris at the right location. So let's go ahead and look at that code. So I'm going to append to the canvas. D is the canvas, which I define right here. Again, 200 by 200 with the origin at the center. I'm going to draw a circle. Where am I going to draw the circle? At x, y. That is where the eye is positioned. The size of that circle has a radius of rad. Notice I'm tapping into the objects, x, y, and radius parameters. I'm going to fill it to be white, and I'm going to set the stroke to be black. So that will create this one big black circle out here, or white circle with a black border out here. Now I have to draw that inner circle, that iris. So let's see here. I'm going to do IX, IY are going to be the position of this blue circle here. and that's specified to be 0.4 times the whole circle's radius times the cosine of the direction plus the self x. Okay, so what's going on here? So just very quickly, and then I'm going to derive this in a slide for you so you can see where the geometry comes from. I'm going to take the i's position, which is the center of the circle, and I'm going to offset it according to this right here. And then I'm going to take the y position, which is this, and I'm going to offset it based on the radius times the sine of the direction. Again, where does r cos theta and r sine of the direction come from? I'm going to derive that in a slide in a few minutes. Now what I'm going to do, once I have this location, I'm going to draw a circle at that position with 1/2 of the full radius. That's just an arbitrary choice. I wanted this blue to be 1/2 the radius of the full eye. And then I'm going to fill its color to be whatever the object's color is, and then I put a stroke of color black, and I'm done. Now, I can go ahead and define a canvas, call my constructor, draw that eye, and then return and then render the canvas, and then I have this. Okay, so at this point, the only thing we have to do is figure out where did this arctan come from, and where's this r cos r sine. So I'm going to pop out of Jupyter Notebook for a minute. We're going to go back to the slides. I'm going to derive that for you. It's not critical that you understand it for the point of objects and classes, but I think if I'm going to give you an equation, that should show you where it comes from. So let's do that, and then we'll come back and look at the face class. Okay, so now I just want to make sure that we understand that look at function and just that little bit of geometry and trigonometry to make sure we understand how to push the eye to look at a particular location parameterized as an orientation. So this is a pretty simple geometry, so let's just go ahead and look at it. This is the outer part of the eye here, the circle. This is the eyeball, if you will. And what we want to do is figure out if I specify some orientation, just some location around the circumference of the circle, how do I position the eye at that position to be looking at, if you will, in that location. So let me just define a few variables. XY is the center of the entire eye, and LX, LY is some point also in this two-dimensional lattice that I want to look at. So if you think about LX, LY as some point here, XY is some point here, there's a line, of course, connecting those 2 points, and I want the eye at that location within some boundary or some distance of the full circumference of this circle. Okay, so of course, this position, of course, is fixed for us, and as that LX, LY moves, that line moves, and then the eye will be drawn at that location. So given that XY location, that LX, LY location, how do I specify where to draw that blue circle right there? Okay. Half of the things in geometry start with drawing a right triangle. So let's draw a right triangle. Again, I've got the line connecting the center of the circle with the point I want to look at, and I've drawn a right triangle right here. Good. And let me remind you that that angle right there, which of course is what is going to be specified, is the arctan of the change in y over the change in x. So that angle right here is the arctangent, or the inverse tan, of the change in y, so that's this ly minus y, divided by lx minus x. And that gives me that angle right there. Okay, good. Now once I have that angle, then I should be able to figure out where this point is if I know the radius. And of course I know the radius because I know the radius of the full circle. So if r is known, I want to know what is that point right there. That has some xy coordinate, so let's figure it out. Let me remind you the other trig identity. The cosine of this angle is equal to this distance, x, over r. Okay, and notice here I have another right triangle right here. Yeah, and so of course this x coordinate right here is that point on the circle. And so of course now x is simply just multiplying both sides by the radius r is equal to r times the cosine of the angle. Again, remember, cosine of the angle is determined by that location and the point that I'm looking at. So I have angle, I know r, that's the circle, and now I have the x coordinate associated with this point on the circle. And now what do I need, of course, is the y coordinate, and that's easy too, because the sine of that angle is the y coordinate divided by the radius. Again, sine of the angle is y over radius, multiply both sides by r, and the y coordinate of that point is r times sine angle. Good, so at this point now, we know how to figure out I want to look at some point out here in the periphery, how do I figure out the xy coordinate in order to draw the eye there? And I just did this little exercise because I have this sort of that magical equation, and I wanted you to just be able to see what that is. All right, let's go back to the Jupyter Notebook, and we'll pick it up there. Okay, now at this point, we understand where these two equations came from in look at and draw. And we have our eye class. We have the constructor. It defines the position, the radius, and the color of the eye. We have the look at, which just will move the iris along a circular boundary depending on where you want to look at it. I'm going to show you why I'm doing that in a minute. And then there's the draw function, which just draws the eye at whatever location and direction that you specify. So there's our eye again. Good. So now let me just show you, of course, that I can do things like draw two eyes. So here is my canvas. I'm going to define one eye to be at location, let's see, minus 40, 0 with a radius of 30. So that is the left eye, EL, pushed leftwards. And I'm going to draw the eye. I'm going to define another eye, ER, at position 40, 0. So I essentially, the origin is here. Left eye goes leftward, right eye goes rightward. And of course, I move just enough so that they don't collide with each other. They both have the same radius, and they're both by default looking at 0, so you get this sort of sideward glance like that. Okay. So that's nice, and that seems to be the beginning of a face, and we're going to do that in a little bit. But let me now just show you the following animation and then show you how I did that. So here's the animation. Let's see if we can get both the animation and the code. Okay, so let's just run that one more time. So you can see the eyes are circling around as if exacerbated by something I just said. All right, let's see what we did here. So this looks pretty familiar. I've got a draw frame. I'm going to go ahead and here's I'm constructing my eyes again, just calling the constructor for the eye class at the same positions as before. And now I have a 4 theta in range 0 to 360 in steps of 5. So let me just remind you what this range does. 0 to 360, so 0, 1, 2, 3, 4, 5, 6, 7, up to 360. But now I'm going to go in steps of 5 instead of steps of 1. I'm going to define the canvas. I'm going to convert this value into radians. So this is in degrees, but of course I need everything in radians. So I'm going to do that using the radians function within the math library. So THR is TH in degrees converted to radians. I'm going to tell the left eye to look at a position 1,000 times the cosine of that angle, comma 1,000 times the sine of that angle. So pick an XY location that is really, really far away. That's the 1,000, 1,000. And look at that position. So notice here that this look at function is the one that we defined in the eye class. And I pick some point here, and I'm going to look at that. And then I'm going to move the right eye to the same location. And then I'm simply going to run my animation loop. Okay, so this animation loop here calls draw frame. All draw frame has to do now is just draw the left eye, draw the right eye, and return the canvas. So we come back in, we pick a new location, we move the eye. And by the way, I could have moved this into here and increment it by some amount. Lots of different ways I could have done this animation. That's how I chose it. Now you may be wondering why I went to all this trouble. So the look at function takes a point x, y, but the eye position is specified as orientation or direction, so I have to switch between the two of those. I could have done it different. I could have said that look at takes as input a direction, in which case I would have avoided some of the geometry I had to do. The reason I did it this way, by the way, is legacy. This used to be interactive, where you would just the eyes would actually move, follow the mouse. The mouse was specified in an XY location, and so this is just a little bit of legacy code which I had to remove because tracking the mouse in Jupyter Notebook turns out to be a bit of a pain in the butt for everybody. In any case, it doesn't matter. It's really just a matter of converting from an XY location to a direction. Once you figure out the geometry, it's all relatively easy to do. All right, so now you can see that we can have a little bit of fun with this animation. by getting the eyes to look around. And we can have the eyes, of course, move in any direction. We can have them move randomly and go back and forth, and you can sort of start to animate this face a little bit. Well, let's say I wanted to create a face. So let's go ahead and let me go ahead and look at this. Something like this. So what is this? This is, I have the outer circle, that's the face, the head rather. I have the nose and the mouth, and then I have the two eyes. So of course, if I'm going to build a face class, which is what I did, I'm not going to go to the trouble to rebuild the eyes. The whole point of these classes and these objects is once that's been done for you, I don't want to have to worry about it. So what we're going to do is we're going to build a face class, and now you could be asking, well, why do I need a whole class for a face? All it is a couple of drawings around these eyes. I could have just taken this code from up here, just draw the two eyes and slap some graphics around it. The reason is that for the drill that's going to follow in the next lecture, you're going to build a crowd class. And the crowd class is going to be built by grabbing a bunch of faces and slapping them onto your canvas. And so you can see now we're building up class after class after class. The crowd is made up of faces. The faces are made up of two eyes. Okay, so let's just build one face for now, and then you can deal with the crowd down the line. My face class has three functions: init, look at, and draw. So the init, of course, is the constructor. Its job is to build where the face is and put the eyes in it. The look at is to make sure that the whole face, that is both eyes, are looking where you want it to look. And the draw, of course, is responsible for drawing the entire face. Okay, so let's go figure out what all the pieces are. So here, x, y, and size are the center of the head, and the size is just what is the radius of this outer circle right here. So my face is going to have an x, y location and a size, and it also has two eyes, which are objects of type I. Now, I don't have to define the nose and the mouth because those are just being drawn. So all I have to specify is where is the face, how big is it, and then when I draw it, I'll fill in all the details based on location and size. But I definitely need the eyes. Why do I need the eyes? Well, eventually I want to be able to get the face to look at something. So if it has to look at something, I need two eyes. So I'm going to define a left eye and a right eye, which are associated with the object of type face. This is a face constructor. What is the left eye? Well, it's an eye. So I call the constructor for the eye class. Where do I put the eye? I take the XY location of the face, that's the center of the head, and I slide leftward by 40 pixels and upward by 50 pixels. How did I figure those out? I just sort of winged it based on some average sizes that I want of the face. And then the right eye is rightward 40, upward 50, so the eyes are offset from the origin, one to the left, one to the right, and then the radius is 30. I probably should have made this radius proportional to the size, because as I increase and decrease the size of the head, the eyes are going to stay exactly the same size. That's a little weird. They probably should be proportional, but let's not worry about that right now. Now, how does a face look at a particular point? Same user interface, pick a point, and I want the eyes to look at it. Well, at this point, I don't have to worry about this. Why? Well, because the face is not looking, the eyes are looking. Well, how do I get an eye to look? I call the eyes function. The eye gave me a look at function. So when I tell the face to look at something, all I have to do is tell the left eye to look and tell the right eye to look, and I'm done. So how do I tell the left eye to look? Self is a face. It has 5 pieces of data, x, y, and size. Those aren't helpful to me right now, but it also has the left eye and the right eye. So I'm going to say, grab the left eye and call that left eye's look at function. Notice that this look at and this look at have the same name, but there is no confusion here. Why? Because this is a face function. So this function will get called when I define a face and say face look at. This function look at, which we defined up top in the eye class, will get called when I say left eye dot look at. So I'm going to simply take the parameters I specified here and pass them on to the eye and tell that eye to look at it. I'm going to tell the right eye to do it, and I'm done. Power of abstraction. The face doesn't care about the geometry, the sine, the cosine, the radius, the angle. None of that is my problem. Once the eye class is built for me, I am home. Okay, good. So the look at function now is trivial. Now, what's the draw going to do? Well, we just got to do a little bit of graphics. fixed. So let's see, we're going to draw a big circle at x, y in size. That's that outer circle. I'm going to draw the eyes. How do I do that? Well, this is trivial too. Why? Well, because I've already got a draw function for the eye. The eye gave me that function. I don't have to redefine it. So I'm going to simply say the same way I called the look at function associated with the left eye, I'm going to call the draw function associated with the left eye and the draw function associated with the right eye. Done. Don't care how it did it. Don't care how it figured out how to draw where to draw the iris. Not my problem. That's been abstracted out for me. And then I've just got a little bit of code here for drawing the nose and the mouth. The nose requires this path, function, which I won't get into, but basically it's just drawing two linear connections, which I specify here. And then the mouth is using this arc. So if you haven't discovered this, you can do arcs as well as circles and squares and other types of simple shapes. Good. So now I'm going to define my canvas. I'm going to initialize a face, and I'm going to simply say face look at 0, 0. So 0, 0, of course, is here. So both eyes go inward, and it's as if I'm cross-eyed. And then I'm going to draw the face, which, again, draws the eyes from the eye class, draws the head, the nose, and the mouth, as I just specified up in here. So look at the power of the abstraction here. The power of the abstraction is once I've defined how the eyes work and how the eyes move and how you render them, people who then use that class, and I will acknowledge that there's not many that we use in eye class, don't have to worry about it anymore. It's been solved for you, and you simply have the power to do that. Now, you may be wondering is, well, why did I have to write this look at function? Why couldn't I have just told the face to call the left eye's look at function? Well, you want to abstract that out. I don't want the user down here to have to worry about what class has been embedded in this class. So again, these are all about powers of abstraction, right? So there's a power of abstraction in using the eye class, and then there's a power of abstraction of defining the face class and then just having the user know that there's a look at function, how it works, the fact that it calls another object's functions, not my problem, and I just don't care at this point because it's already been written for me, and now I can just use it. Good. So at this point now, we've done 2 new classes. Hopefully I've reinforced some of the basic ideas, and you've seen how we can embed one class within another class and that power of abstraction. When we come back, I'm going to describe a new drill for you that probably will take a little bit longer, but is absolutely worth doing to make sure that you can write these classes and that you can use the classes within each other. That's a very, very important concept in object-oriented programming. So we'll be back in a little bit with that drill.